I'm meteorologist Ryan Hanrahan. Want to update you on the severe weather threat that is growing across New England and the northeastern U.S. from Maine all the way down toward New York City and even as far south as the mid-Atlantic. There is a risk for some tornadoes today, along with gusty winds and hail. And that main threat for, it looks like tornadoes is going to be across portions of New England, and that threat for damaging winds and hail extends farther down to the south into the mid-Atlantic. So let's take a look at what's going on right now. I'm going to start things off with a visible satellite loop, and you can see we've got plenty of sunshine from basically along the I-95 corridor from Maine all the way down into New Hampshire, portions of southern New England, and then back toward New York City and New Jersey. And so the sun is out. It's turning warmer. It's quite humid out there, and so the atmosphere is becoming quite unstable. That sunshine is really allowing the atmospheric instability to build, and we do have thunderstorms that are popping up now across the Catskills up toward the Capital District in New York, and so a pretty decent line starting to form here. No severe weather yet as of about 10 of 1, but as this line moves to the east, we are expecting it to strengthen. It's moving into a more unstable air mass. And there's also quite a bit of wind shear in the atmosphere, and that's going to help organize these storms. So out ahead of the thunderstorms, again, quite unstable. We've got temperatures around 80 degrees from Boston down toward Hartford, mid-80s around New York City. So we've got a lot of warmth here. You can see the front very clearly. Look at the temperatures here. It's only 59 in Binghamton, New York, 61 in Albany, or at least in Schenectady and Glens Falls, and then you've got that warmer air to the south, and so it's that warm air and where you've got the moisture, that's where we've got that severe weather potential. And the dew point temperature is a little higher than what was forecast yesterday, so a little bit more moisture in the atmosphere, which will only increase that severe weather threat. Dew points now in the mid-70s, 74 degrees at Hartford, mid-70s down toward New York City, 74 in Philadelphia. So all that humidity is just going to serve to increase the instability. When you factor in the wind shear in the atmosphere, that's a problematic combination. You can see the front pretty clearly here. The winds are out of the south, pretty gusty across southern New England, sustained winds 10 to 15, gusting up to 25, and so you've got a lot of convergence along that front, and that convergence, that low-level convergence where the air comes together, that's where the severe weather is going to form. That's where the storms will form, and then they'll move to the east from there. So let's take a look at some of our computer guidance. I want to show you, this is a look at the instability in the atmosphere, and we'll head to about 2 o'clock this afternoon, and you can see across portions of northwestern Connecticut, the Hudson Valley, quite a bit of instability. Mean layer Cape, about 2,000 joules per kilogram. That is a lot for us here in New England. Outside of Boston, same deal, near New York City. So there's quite a bit of instability here just inland from the I-95 corridor. And so this is the area most at risk for severe weather. And as we take a look at the low-level wind shear, there's quite a bit of that as well. I'm going to stop the clock here at 2 p.m. and you can see you're looking at about 250 units. Over the Berkshires, even more, close to 300 units of low-level storm relative helicity. And that storm relative helicity, once that gets ingested into these thunderstorms, that can be enough to produce rotating thunderstorms, or what we call mesocyclones. And so those rotating storms may be developing as this line moves to the east, especially when we get some storms out ahead of the main line. And that's why we've got that tornado potential across portions of New York, Connecticut, Massachusetts, up into central New England, Vermont, New Hampshire, and even portions of southern Maine. So it doesn't look like a tornado outbreak where we've got a swarm of really strong tornadoes, but I do think there's enough instability and there's enough wind shear in the atmosphere that some embedded tornadoes, certainly a possibility later today. Where exactly that sets up is a little hard to know at this early juncture, but we'll have a better idea as these storms start to move in. So stay weather aware as these storms approach, and as we take a look what some of our computer models are showing in terms of where they're projecting those rotating storms to be. This is what we call updraft helicity. And so basically what we're doing here is these computer models are trying to predict which thunderstorms will rotate. And there's a big, the big error bars here. The computer models don't exactly know where this will be, but where you see some clustering, that's where you've got a better chance, where a majority of the computer models show these rotating storms. And you can see there's quite a cluster here from the Hudson Valley, northwestern Connecticut, up through central Mass, then into portions of Maine and New Hampshire. Pretty impressive signal here where you've got these spikes in updraft helicity. So rotating thunderstorms, tornado potential certainly there, and this model certainly shows that. This is actually the high resolution ensemble forecast, so it's a bunch of models all merged into one, so we can look at trends and we can look at where the models show the best agreement. And that, again, north of New York City, Hudson Valley, up into portions of New England. I wanted to look at the RFS because this is updating literally as we speak. So let's take a look at what it's got. This is also looking at updraft helicity here, and it's got some pretty big signatures here from the Hudson Valley into the Berkshires, parts of Connecticut, and portions of Vermont and New Hampshire and Maine, excuse me. So again, this is the area that we're sort of highlighting for that tornado potential, though severe weather risk does extend farther south into portions of the mid-Atlantic as well. So to get severe weather, you need a couple things. You need instability, you need wind shear, and we've got plenty of that. You put all that together. You put together the instability, you put together the low-level wind shear, and we can sort of plot it here for you. In this area across New England, pretty much from about New York City on north into Maine, this is highlighted as an area where there's a lot of overlap between all of those fields. And so because of that, that's where we got the potential for severe weather. No real changes here. Everything looks about the same as it did yesterday. So again, severe weather moving in this afternoon. It should wind down pretty quickly. I think most of it's probably done by, let's say 7 o'clock. We lose the heating of the day. The storms will begin to weaken. The outflow will take over from these storms, and then the threat will go down. But some rain may linger, and I think some of the rain lingers into, unfortunately, Sunday as well. And just pulled up some of these soundings here. This is a vertical look through the atmosphere. So instead of looking at a map where we're looking across a region, I'm picking one specific point and looking at how the atmosphere looks from the ground all the way up. And you can see this is 3 o'clock. This is an area in northwestern Connecticut. A couple things to note here. There's a good amount of instability. The area between the red is the temperature line. The blue is where a theoretical air parcel would rise. And the greater the distance between that and the temperature profile, the faster it will accelerate up and the better chance you have for some thunderstorms. So there's quite a bit of instability here. No surprise there, but there's also quite a bit of wind shear. You can see the winds at the surface are out of the south-southeast, but then you move aloft and the winds are out of the southwest. And so the wind is sort of turning, is veering with height, and that allows the low-level shear to build. That is low-level shear, and you can see that here in the hodograph. If we plot the wind, if we plot wind vectors every, 500 meters or so, and then you draw a line at the end of all those vectors, you get what we call a hodograph. It's basically a look at the wind field through height, and the more clockwise curvature you've got, the better the low-level wind shear, and there's a decent bit of it here, and so this is certainly a sounding that would indicate the potential for tornadoes, and this is another one here, just a bit later in time. This is at 5 o'clock, and same deal. You've got the strong low-level flow, instability, and so these storms as they organize, certainly producing the potential for severe weather. So we're going to keep you posted on the storms. We'll update you throughout the day. Stay weather aware. No need to panic. No need to freak out. This is something we get a couple times every summer. It's been a quiet severe weather season so far this year, so we haven't had a lot of these. But this is a scenario that we see every once in a while here in New England. It's unusual, but again, we see it once or twice a summer. And this is a day where we could have some severe weather and, again, potentially some tornadoes as well. So stay safe today. Stay weather aware. And then some good news is we've got some beautiful weather moving in starting on Monday. I think tomorrow's a little iffy. So thank you so much for watching. Make sure you subscribe, like this page. I'll try to do my best to respond to any comments if you've got them today. And hopefully we'll see you again soon. Have a great one.